Question 9. So what we have to do is we've got to look at differentiating this. Now the problem is that we've got x and y's and they're all mixed up, and that makes it a little bit more complicated. So we apply implicit differentiation. So it's going to look like this. I'm going to write it over here, so just so I've got a little bit more room and you can see it next to it. So how do we set this out? It's going to look like this. We think about just differentiating with respect to x. So what I'm going to do is I'm just going to write down each term as we go. I'm not going to try and do anything straight away. Just going to set it out at how we're actually going to work this through. So plus d over dx 3y squared, and then the last bit is going to be, again, differentiate 50. There you go. Ooh, just about to see that. There we go. Right, okay. So let's concentrate on the easy bits first of all. I can do that bit. Not too tricky. That's just going to be 2x, and this part just here, well, that's just going to equal 0. If we differentiate this with respect to x, just going to disappear. Right. Okay, now the next couple of parts. Well, let's concentrate. Let's maybe look at this bit next, which isn't too bad. So if I differentiate this, that's going to give me 6y. So when you do y, it ends up like this. Okay, I'm not going to go too much into that, but you might need to go back and have a little look at your implicit differentiation. And then this section in here, what does that look like? Well, we split that up and it's going to look like this. So because it's got an x and y in there together, and then plus exactly the same but just the other way around. There we go. Okay, right. So we're nearly there. We just got to deal with this part just here. Let's talk about what that's actually going to give us. Well, this one's the easier one to begin with because that's just 2 there. So that's going to give us just 2y. This one, slightly trickier to do. If I differentiate the y, remember you're going to end up getting here, you're going to get 2x with dy over dx. Got a plus there. Remember it's minus the whole thing. Alright. Okay, let's just tidy up where we are and also think about what we're actually trying to get to as well. Alright, so we want to get dy over dx is equal to, right? Remember, that was our question just over here. So let's just tidy up where we've got here. Let's get rid of this bracket to begin with. So what's that going to give us? 2x minus 2x dy dx. And then that's going to be a minus there. Minus 2y. And then plus 6y. Now the rest of the question isn't too bad, to be honest. We've done the worst bit of the question. So let's get anything that hasn't got dy over dx over on the right hand side. So let's we'll add 2y, take away 2x, and that leaves us, and then that's going to leave us with that part there. I'm going to take out dy over dx as a common factor. So dy over dx, and that's going to give us 6y, take away 2x. I was like to write the negative at the end if we can. Divide both sides by this. So dy over dx is equal to 2y minus 2x over 6y minus 2x. And that's equal to y minus x over 3y minus x, which is what we wanted. Right, okay, let's have a look now at part B of the question. Right, so let's go back and have a look at part B. Now it says here, now remember, it's a show that question, isn't it? So on a show that question, you can be sure it's told you this. We need to use it down here. So let's think about this, what it actually is asking us to do. It wants us to do this. It says find the exact coordinates of P. Right, what do I know about this? Well, I know the gradient is infinite. So in other words, when is this part going to be infinite? And it's going to be infinite when the denominator is 0. So we can write down 3y minus x equals 0. So in other words, x equals 3y. Right, what do we do with that now? All we got to do is let's just feed that information into here, and then we can find out a value for y. So if we feed that in, let's just quickly see what we end up with. We're going to get 3y squared, okay, because we're doing x squared there, but look, nearly made a mistake there, because it's 3y squared. And then we're going to take away 2 multiplied by x. Instead of writing x, I'm going to write 3y, and then multiplied by the other y, and plus 3y squared, that equals 50. Okay, let's just tidy this up. What have we got? We've got 9y squared. Going to take away 6y squared plus 3y squared equals 50. And I think you'll find there that that's going to give us, so 6y squared equals 50. Divide by 6. So y squared equals 50 over 6. So if we take the square root of both sides, then y should equal square root of 50 over 6. Oh, so you just pop that into your calculator, can't you, really? That's going to give us 5 root 3 over 3. Now, it's the negative, right? There are obviously it's a plus and a minus, but we're looking at P, so it's the negative point there. So we know it's going to be that value. Okay, there's the y point, and then the x point. Wait a minute, x equals 3 times y. Oh, it's just that times 3, isn't it? So the value of P is just going to be minus 5 root 3. That's the x value. And then the y value is going to be over 3. Oh, you've got the negative just there. All right, we're done. And then on part C, is explain briefly how to find the coordinates of the point that is furthest north of the origin. So we're looking at this point up here. So obviously it's when the gradient is equal to 0. So in other words, what we're looking for is when is dy over dx equal to 0. That would only be this numerator part. So in other words, when is y minus x equal to 0? When is y equal to x? Feed that back into there. All right, there you are. Question 9 done.